It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Hello everyone, good evening all. Welcome to Unacademy. So let me introduce first. My name is Banu Prakash. I did MTech from NIT Kurukshetra. I have 10 years of teaching experience, especially in the GATE field. And I train many students throughout our country for different competitive exams like GATE, ESE, Transco, GENCO, and many more exams. My subjects are electrical machines and power electronics. BPC 10 is my referral code. Use this code, you will get 10% discount on Plus subscription as well as Iconic subscription. And what are the benefits of the Plus and Iconic subscription? By taking Plus subscription, so you can get live classes from the top educators of the country, and also you can join the cross courses rank improvement batch. You can we have a weekly test also. By using this weekly test, so you can analyze your performance week by week, and also we have a doubt solving session. It is a very useful for your GATE and ESE preparation. So these batches, rank improvement batch, cross course, all the both batches are in the English or Hindi. You can choose any one, either English or Hindi. And also another subscription, that is Iconic subscription. So by taking Iconic subscription, that is so we will get one is a personal coach. Here we will get one-to-one guidance, and it is a very useful for your GATE and ESE preparation. And also customized study plan, and by using this you can track your performance. And another one is the study booster sessions. Okay, receive the essential guidance via regular workshops. Okay, one more advantages of the Iconic subscription, that is a personalized test analysis. Okay, that is in-depth analysis of the test by sections and the question type. So it is also very useful for your GATE and ESE preparation, which improve the GATE rank in the any exams. Okay, and another one is a study plan materials. Okay, here we'll get specialized notes and practice sessions. Okay, practice set of questions. So these are the benefits of the Plus and Iconic subscription. So by taking Plus and Iconic subscription, okay, while taking, use my code BPC10. So this is the code. Use this code, you will get 10% to discount on the Plus subscription as well as Iconic subscription. And what about the price for the Plus and Iconic subscription? Plus is available for the 12 months, 18 months and 24 months. So for 12 months, fees are 27,225 rupees. Okay, for 18 months, fees are 34,650 rupees. Okay, for 24 months, fee is 39,600 rupees. Another subscription is Iconic subscription. It is available for 12 months and 24 months. For 12 months, fee is 45,225 rupees. For 24 months, fees are 66,600 rupees. So this all about fee structure of the iconic subscription and also plus subscription. So how to install this Unacademy learning app? Okay, go to Play Store and just search Unacademy learning app in the Play Store, and after that install the learning app, okay, in your phone. So after that, okay, use my code BPC10 so to access the pre-special classes. Okay, it is the BPC10 is a my code. So to access the pre-special classes and Unacademy learning app, okay, use this code. And the next one, and this is the Unacademy GATE Telugu December month schedule. Communication system 4 to 5:30, electrical machines 4 to 5:30 p.m., engineering mathematics, okay, 4 to 5 4 5:45 p.m. to 6:45 p.m., power system 7 to 8 p.m., and aptitude 8:30 p.m. to 9:30 p.m. Okay, these are the regular classes. And another one, crash courses. Okay, one is a power electronics, EDC, and aptitude. So power electronics is class from 4 to 6 p.m. EDC class is from the 4 to 6 p.m. Aptitude is 7 p.m. to 7 p.m. to 9 p.m. Okay. Good evening all. Pawan, good evening. Sanjana, good evening. How are you? So these are the plus batches taken by the top educators of the Unacademy. One is a Target ES Prelims 2021 Electrical Batch D. Another one is Rank Booster Batch for the GATE 2021 for ECE Batch D is running now. And Target ES Prelims 2021 Electrical Batch C and Rank Improvement Batch for the GATE 2021 Electrical Batch. So to utilize all these batches, please join Unacademy as early as possible. Take the subscription, either the plus or iconic subscription. Okay. And some good news for our channel, that is the legendary educator is coming on the 15th of the December at 6 p.m. Okay, be live at this time exactly. Don't miss this live class. Okay, Unacademy Combat. It is the big test series. It has India's largest competition for the GATE, challenging GATE questions created by the best educators of the country. And also one more advantages of the Unacademy Combat, that is the super fast fun with the real-time rankings and compare with the best. Okay, that is the battle of the best live and detailed video solutions by the top educators. So it is a December 16th, not the 13th, and this one is the December 16th at 6 p.m. Okay, 6 p.m. Register as early as possible. And also by competing this one, you can win some exciting prizes also. One is the Apple MacBook, Apple AirPads, Apple iPad Mini, and top 100 rankers, 1000 Amazon vouchers. Okay. Bharat, good evening. Sir, okay. Lecture number 50 notes upload చేయలేదు సార్. ఓకే, చేశాను అనుకుంటాను. ఒకసారి మీరు చెక్ చేయండి, అదర్వైజ్ ఐ విల్ అప్లోడ్ టుడే. ఫైండ్ మీ, వాట్ ఈస్ యువర్ నేమ్? హాయ్ సార్ భరత్, గుడ్ ఈవినింగ్. Okay, today I will upload it, lecture number 50 also, after this completing this lecture. Sure. Satish, hi. Okay, this is the diagram yesterday we had discussed very clearly. So how do we design the lap connected armature winding? YB and YF relation. Chappan Satish, what's your question? YB or YF relation? What's your question? Mention your question clearly, then I will explain it. Okay, YB in the lab, here progressive lab connected armature winding, for progressive winding, progressive, okay, YB is greater than the YF, okay, and for retrogressive lab connected armature winding, so YF is a greater than the YB. Depends upon the progressive and retrogressive lab connected armature winding. Progressive winding means winding connections are moving in the clockwise direction, whereas winding connections are moving in the anti-clockwise direction. That winding is treated as a retrogressive nature of the windings. Are you clear now? Any more questions? Okay, so previous class we had discussed about what is meant by the lap connected armature winding, and also what are the terms belongs to armature winding, that is especially in the lap connected armature winding. So that is the back pitch, front pitch, commutator pitch, and also resultant pitch. And the next one we had discussed about how to design the lap connected armature winding. So what are the designing specifications? Okay, we have a for progressive lap connected winding, YB is equal to Z by P plus 1, whereas YF is equal to Z by P minus 1. Z is the number of armature conductors, P is the number of the poles. Okay, and after that we had discussed about what are the how to place the braces on the commutator, how do we get the number of parallel paths equal to number of the poles in the lap connected armature winding. This part we had discussed in the previous class. Okay, is that clear everyone? Okay, all these parts we have discussed in the previous class. So today we will discuss about the what are the observations from the lap connected armature winding. Okay, it is a very important one. Or what are the possible questions from the lap connected armature winding? Okay. So first question. So we have a question number 1 from the lap connected armature winding. So that is a number of the parallel paths in the lap winding. Okay, this is the number of parallel paths in lap winding. Okay, so it is denoted by A, so that A is equal to P, where P is the poles. Okay, in this case where P in the sense, so it is a number of the poles. For example, here how many number of poles in the lap winding? 4 number of the poles. So here in this diagram, number of poles is the north pole, south pole, north pole and south pole. So poles are equal to, okay, 4, And how many number of parallel paths here? A is also equal to 4 number of the parallel paths. So that's why we have written here. So that is the number of parallel paths in the lap winding, A equal to number of the poles. This is a generally it is a equation A is equal to P. But sometimes we have a question, the number of the parallel paths per duplex winding and number of the parallel paths per simplex windings. Okay. So one more observation. So that is a number of parallel paths per triplex winding or number of parallel paths per multiplex lap connected armature winding. So duplex, simplex and multi. So your note is a unless otherwise specially mentioned. Okay, I will tell you all the number of parallel paths. So what is the note? Unless otherwise specially mentioned, the that is a lap winding in the sense winding in the sense, okay, simplex lap winding only, simplex lap winding only. Okay, so this is a number of the parallel paths per simplex lap winding is equal to, therefore number of parallel paths for simplex lap winding, so that A is equal to the P only here. Okay, so but we have a question, number of the parallel paths per the duplex lap connected armature winding and number of parallel paths per triplex lap connected armature winding. One more question, number of the parallel paths per the multiplex lap connected winding. So before discussing about the parallel paths, so we have to know about what is the meaning of simplex, duplex and triplex or multiplex. Okay, so this type of, why we are using this, the number of parallel simplex, duplex and triplex lap connected armature winding. So another observation is, okay, so that is a number of the parallel paths. Okay, number of parallel paths for, okay, multiplex winding, multiplex lap winding. Okay, how do we get number of parallel paths per multiplex lap winding? So that is a M multiplied by P here. Okay, M multiplied by P. So what is the M? Okay, M is a multiplexity factors. Okay, so where M is a, okay, in this case, so where M is the multiplexity factor, okay, and what about the P here? So P in the sense, so that is a number of parallel paths, number of the parallel paths. Got it? M is a multiplexity factor and P is a number of the parallel paths. So per simplex winding, okay, per simplex lap winding, okay, for simplex the lap winding, so that M is equal to, okay, M equal to 1. Okay, similarly for the duplex lap connected armature winding, okay, so this M value is equal to, okay, 2. Okay, M is equal to 2. So per triplex lap winding, so what is the M value here? m is equal to the 3. Okay, m is equal to 3. So now we have a question. What is the meaning of simplex lap winding, and what is the meaning of duplex lap winding, and what is the meaning of the triplex lap winding? How do we design the simplex lap connected armature winding? How do we design the duplex lap connected armature winding? Another question, how do we design the triplex lap connected armature winding? So simplex lap connected, that means in order to get the simplex lap connected armature winding, so commutator pitch is taken as a YC is equal to plus or minus 1. Okay, YC is equal to plus or minus 1. So where plus is for progressive lap connected armature winding and minus is for the retrogressive lap connected armature winding. So that means ends of the coils are connected to the successive commutator segments. Okay, as shown in the figure. So that is here in this figure. So this is the finishing end of the second coil. Finishing end of the coil is connected to the second commutator segment. Okay, connected to the starting end of another coil through commutator segment. So what is the difference between C1 and C2 here? Only one commutator segment. Suppose to get the duplex lap winding, what we have to do here? So it is connected at the 3. Okay, difference here 3 minus 1. So we will get the duplex lap winding. Okay, are you clear point? So that is in order to get the in order to design the duplex lap connected armature winding, so we have to take commutator pitch YC is equal to plus or minus 2. Okay, and in order to design the triplex lap connected armature winding, so YC is equal to plus or minus 3 here. So that is this is per, so this is to get, okay, to get the duplex, to get the simplex lap winding. Okay, simplex the lap winding. So this is per to get, okay, duplex lap winding. And this is for the to get, so or to design the triplex lap winding. All of you got in point what is the meaning of the duplex winding, triplex winding, and so this commutator pitch is YC is equal to plus or minus 1. Commutator pitch is the plus or minus 2. Plus sign is per, so where plus sign, okay, in this case plus sign is for the progressive lap winding. Okay, progressive lap winding, and minus sign here. Progressive lap winding means connections are moving in the clockwise direction. Minus is for the retrogressive lap connected armature winding. So these connections are moving in anti-clockwise directions. Okay. Duplex not understand. Okay, Pawan, I will explain. Don't worry. See here. What is the commutator pitch here? So this is the example is a, so this figure is a simplex lap winding. Simplex progressive lap winding. Okay. All of you got in point? Simplex progressive lap winding. So in this case, what is the commutator pitch here? Y2 minus 1. Commutator pitch YC is equal to, so that is the 2 minus 1 here. Okay. Suppose in order to design the duplex lap winding, okay, this is the finishing end of the coil. So this coil is connected to the starting end of another coil through commutator segment C3, not at the C2. Okay, that time what will happen? Commutator pitch here. So YC is equal to, okay, 3 minus 1. So it is a 2. Okay, here is a 3 minus the 2 minus 1. So it is a 1. So commutator pitch is equal to 1 commutator segment. So commutator pitch is equal to 2 commutator segment, that is a duplex lap winding. Commutator pitch is equal to 3 commutator segment, that is a triplex lap connected armature winding. Okay. Is that clear, everyone? Okay, so now next one we have another question based on all of it clear, and another observation from the lab connected armature winding. Sometimes we have a question, number of the brush required in the lab connected armature windings. How many number of the brushes are required? So number of brush required, brushes are required in lab winding. Okay, this is, so how many number of the brushes are required in the lap winding? First, how many number of the parallel paths? 4 number of the parallel paths. So now that is a number of the brushes are required. So for simplex winding, okay, for simplex lap winding, okay, so that is equal to number of the parallel paths. Okay, so now it is equal to number of the poles. Okay, and similar way another one, so number of the brushes required. Okay, sometimes we have a question, so number of the brushes are required, okay, required in multiplex lap winding. So that is a is equal to, so here A, so that is equal to M multiplied by P. Okay, so this is also multiplex lap connected armature winding. 4 brushes, 4 parallel paths are there. Each parallel path connected between the positive group of brushes and negative group of the brushes. So that always number of the brushes are equal to number of the parallel paths. In the lap winding, number of parallel paths are equal to P for the simplex lap winding. Simplex lap winding means the commutator pitch is equal to 1. Duplex lap winding, commutator pitch is the 2. So that means we have to take the commutator pitch is equal to 1 for simplex lap winding. We have to design the winding by taking commutator pitch is equal to 2 for duplex lap connected armature winding. So now we have a question, so that is a why duplex and triplex and so on. So that is the we have a question. So why duplex winding, okay, duplex or the triplex, okay, this is the triplex winding, okay, winding required, okay, this type of question in the competitive exam. So what is the reason? So as suppose per duplex winding, so number of parallel paths is equal to per 4 pole machine. The example point, so that is the number of, okay, here is a per the P is equal to 4. So per simplex winding, so what will happen? So per simplex, so that is a number of parallel paths A is equal to P, that is equal to 4. So now A is equal to, so now per same number of the poles per duplex winding, so it is equal to, so that is a is equal to M multiplied by P. So where M is a multiplied by, okay, that is a 4, okay, 8. So as parallel paths increases, okay, this is the as the parallel paths increases in the winding, okay, increases. So then what will happen? Current rating of the machine, okay, current rating the will be increased. So here the parallel paths increases, current rating of the machine will be increased. So what is the requirement here? So multiplexity winding is required to increase the current rating of the machine. Sometimes suppose actually lab connected winding is used for the low high current and low voltage application. Suppose it is used for very high amount of current rating application. So how do we design? So that is so we can use the whether it is a duplex and triplex winding depends upon the application of the current rating of the machine. Okay. So why duplex triplex winding here? To increase the current rating of the machine. to increase current rating of machine. All of it clear now? This is the fourth possibility question. Okay. So now let us discuss about another observation, fifth one. Fifth one here. So now we have a question, fifth. So that is so whether lap winding is complete winding or incomplete winding. Okay, this is also one of the question. Can you answer? Whether lap connected winding, is it complete winding or incomplete winding? Be fast. Write the comment on the comment box whether it is a complete winding or incomplete winding. Very good. Complete winding. Complete winding. What is the meaning of complete winding? Complete winding means that no slots in the armature core is left empty. So that is a complete winding. So here we have started here in this case. Okay, in this diagram, see, all the slots are filled with the coil sides, or all the slots are filled with the two conductors. No slot is left empty. Okay, this type of the winding is known as the complete winding. Okay. So here one more observation, that is lap winding is complete winding. Complete winding. So that means no slot in the armature core. No slot in the armature core. Armature core is left empty. Okay. So suppose if we take, so this is the armature core, like we have a armature core here. So in this armature core, so some slots are the left. Okay, this is the slot 1 here. Okay, slot 1, and this is the slot 2, like, and here slot 3, slot 4, okay, slot 5, slot 6, okay, slot 7, and slot 8. Okay, all the slots are filled with the armature coil. So it is the open type slots, right? So it is the one slot. Okay, now this is also another slot 1 and slot 4. Okay, slot 5, like slot 6, slot 7. Okay, so that 1 2 3 4 5 6. Okay, this is the 7 and 8 number of the slots. So therefore here slots of the machine, so that is the S is equal to 8. So now in double layer winding, each slot is filled with the two coil sides. So now here it is a single turn coil. The turn coil. Okay, single turn coil. So therefore Z is equal to 16, and P is equal to how many number of the poles here? 4 number of the poles. So it is a single turn coil, that's why Z is equal to 16. So here each slot is filled with the two coil sides, like 1 and 2. One is the upper plate and this one is the lower portion. So upper portion and lower portion, like so on. Upper portion and the lower portion. Okay. So what we conclude here? So this is the mechanically balanced well. Okay, mechanically balanced well. So lap connected armature winding is a complete winding. That means no slot is in the armature core. Okay, armature core is left empty. So if there is no that is a no slot is left empty. So that's why, okay, that's why. So what will happen? That's why. So we can say that, okay, dummy coils. Okay, dummy coils are not required. Are not required in the lap winding. Required in the lap winding. Got it? So what is the meaning of dummy coils? Dummy coils means which is also coil. Okay, it is also coil, but it is not connected in series with the armature winding. It is only placed on the core to get the mechanical balance. So the lap connected armature winding is a mechanically balanced well. So here is a lap winding. Okay, this is a lap winding. So is mechanically balanced well. Okay, balanced well. So that, yeah, that's why dummy coils are not required in the lap connected armature windings. Okay. వంశీ వన్స్ తెలుగులో చెప్పండి సార్. నువ్వు నిన్న క్లాస్ నువ్వు ఫస్ట్ నిన్న క్లాస్ వినండి, మీకు ఈజీగా అర్థమవుతుంది. నేను మాట్లాడే ఇంగ్లీష్ పెద్ద ఎఫెక్టివ్ ఏమి ఉండదు, మామూలు ఇంగ్లీషే, నీకు ఈజీగా అర్థమవుతుంది. నువ్వు రెగ్యులర్ క్లాస్ ఫాలో అయితే ఈజీగా అర్థమవుతుంది. Okay, lap winding is a complete winding. That means no slot in the armature core is left empty. Got it? So lap winding is a mechanically balanced well, so that dummy coils are not required. Any more question do you want to ask? Only dummy coils are used in the wave winding. That part I will discuss whenever we have a discussion about the wave connected armature winding. Okay. So now let us discuss about the sixth one. So that is a very important. Okay, this sixth one. So it is a equalizer rings. So what is the meaning of equalizer rings here? Okay, first one, it is also one conductor. So it is a ring is provided. So like, okay, suppose where we have taken, so that is a equalizer ring. Okay, ring is a provided in the armature. So it is always designed with the thick conductors. Why it is thick conductor, I will tell you. So this is the one ring, equalizer rings. Okay, so it is designed with thick conductor. Here. So it is the equalizer rings. It is a design with a thick conductor. So now we have a question. Why it is a thick conductor? So thick conductor means, okay, area of the cross section. The thick conductor means area of the cross section. Cross section is high value. Okay, high. When area of the cross section is a high, so then what will happen? the resistance of the equalizer ring. Okay, equalizer ring. So that is equal to okay rho L by A. So when area is a high, okay, area of the cross section is high. So resistance of the equalizer ring is a low value here. So that is the resistance of the equalizer ring. So is the low value means. So our purpose is, so any sparking occurs at the brushes. Okay, any sparking occurs at the brushes. So if there is a ring, so then what will happen? It provides the low reluctance path, okay, to flow the circulating current within the ring only. So that's why equalizer rings are provided in the lap connected armature winding. So what we conclude here, so equalizer rings are, okay, this one is the problem of circulating current. Problem I will tell you very clearly, don't worry. Problem of circulating current between any two parallel paths, is more in lap connected winding, lap connected armature winding. So equalizer rings are connected between the equipotential coils. Okay, equipotential coil. So here we have a question. So many question in this statement. One is a first one. What is the meaning of equipotential coils? And how do we get circulating current between the any two parallel paths? Okay. So generated voltage in the each parallel path remains same. But due to sparking at the brushes, there is a possibility of the circulating current in between the parallel paths. So how do we reduce this circulating current? So by providing the equalizer rings between the equipotential coil. So what is the equipotential coils? Okay, see here. So this is a coil 1. Okay, it is a coil 1. Okay, and similarly this one is a coil 2. Okay, and here this is a coil 3. And here coil 4, and this is the coil 5, and it is a coil 1, 2, 3, 4, 5, and this is the coil the 6. Okay, now this coil is these two ends are connected here. So now it is a coil 7, and this one is the coil, okay, 8. Okay, 8 number of the coil. So now question is what are the equipotential coil? Can you guess, anybody? So in this diagram, what are the equipotential coil? Which one? Which are the equipotential coils? Equalizer rings are connected between the equipotential. Equipotential ante, so same voltage develop suppose coil 1, the voltage generated in the coil 1 is a for example 20 volts అనుకోండి. Another coil also కూడా same coil ఉండి same voltage produce చేసేదాన్ని equipotential coil అంటాం. సో ఈ డయాగ్రామ్ లో ఏ రెండు కాయిల్స్ ఒక ఏ టూ కాయిల్స్ ఒక ఇయర్. సో ఏ టూ కాయిల్స్ will produce the same amount of the voltage at the same amount of the flux. So that coils are known as the equipotential coils. 1 and 5. 1 and 5. Who have given 1 and 5? Sanjana given 1 and 5. Okay. 1 and 5. Why Sanjana? Why these two are equipotential coils? 1 and 5 are equipotential coil. Okay, suppose this is the first one coil, right? Is it clear? It is the one coil 1 and this one is the coil 5. Okay. Okay, this coil 1 and it is a 5, right? 1 and 5 అనే కాయిల్స్ ఈక్విపొటెన్షియల్ కాయిల్. ఎందుకు చెప్పండి ఈక్విపొటెన్షియల్ కాయిల్? కనెక్టెడ్ టు ద సేమ్ పొలారిటీ ఆఫ్ ద బ్రష్. వెరీ గుడ్. సపోజ్ ఈ కాయిల్ 1 లో ఒక కాయిల్ 1 ఉంచుడండి ఇక్కడ కాయిల్ 1 లో. సో ఫస్ట్ కాయిల్ సైడ్ ఎక్కడ కనెక్ట్ అయింది? ఇట్ ఈస్ ఏ ఫస్ట్ కండక్టర్ అండర్ ద ఇన్ఫ్లుయెన్స్ ఆఫ్ ద నార్త్ పోల్. am I right? So this is the first conductor. Just wait a minute. Okay, this is the first conductor under the influence of the north pole. Okay, coil 1 లో okay 1 అనేది first conductor under the influence of the north pole. am I right? So next one coil side 2. okay, coil side 2 ఎక్కడ ప్లేస్ అయింది? it is a second conductor under the influence of the south pole. సో నెక్స్ట్ ఫిఫ్త్ కాయిల్ లో కూడా సో ఫిఫ్త్ కూడా ఈ ఫిఫ్త్ అనేది సో ఇట్ ఈస్ ఆల్సో ఫస్ట్ కండక్టర్ అండర్ ద ఇన్ఫ్లుయెన్స్ ఆఫ్ ద నార్త్ పోల్, రైట్? సో దిస్ సెకండ్ కాయిల్ సైడ్ is the first conductor under the influence of the south pole. So no other two coils are having the same no other two coils are placed in the same polarity of the poles. Only coil 1 and coil 5 are equipotential coils. Okay, got it point? So that's why the ring is provided. Okay, now the ring is a so this equalizer ring okay is connected between the equipotential coils. Okay, like this equalizer rings are provided here. So now already mentioned that it is designed with a thick copper wire. Suppose any circulating current occur at the brushes, then what will happen? So this is a low resistance path, so definitely this circulating current passes through. So this chooses the low resistance path. So that's why current, any circulating current, the air passes within the ring only because it has a low resistance path. Okay, so like this. Similarly, coil 2 and coil 6 is the equipotential coils. Now coil 3 and coil 7 is the equipotential coils, and coil 4 and coil 8 is a equipotential coils. Okay, always equalizer rings are provided between the equipotential coils. So now question is, how many number of equalizer rings are required? Okay, so equipotential coils are so provided. So example point here, okay, in the diagram. So in the lap winding, okay, coil 1 and coil 5 are equipotential coils. Potential coils. Got it? So next one, coil 2 and coil 6 are equipotential coils. The 3 and coil 7 are equipotential coils. Now coil this is the 4 and coil 8 are the equipotential coils. Okay, Okay, see here, Pawan. So this is the equipotential coils, right? Okay, it is the equalizer. Rings are provided here in between these two conductors. Okay, it is a equalizer, the ring. Okay, 1 and 5 ఎలా అంటే నువ్వు కాయిల్ 1 తీసుకోండి. కాయిల్ 1 లో కాయిల్ 1 కు ఎన్ని కాయిల్ సైడ్స్ ఉంటాయి? కాయిల్ సైడ్ 1 అండ్ కాయిల్ సైడ్ 2. కండక్టర్ 1 is a కాయిల్ సైడ్ 1. ఓకే, కండక్టర్ 6 is the కాయిల్ సైడ్ 2. ఓకే, కాయిల్ సైడ్ 2. సో 1 ఎక్కడ ప్లేస్ అయింది చెప్పండి? 1 అనేది ఫస్ట్ కండక్టర్ అండర్ ద ఇన్ఫ్లుయెన్స్ ఆఫ్ ద నార్త్ పోల్. ఓకే, అండ్ 6 అనేది ఎక్కడ? దిస్ ద సెకండ్ కండక్టర్ అండర్ ద ఇన్ఫ్లుయెన్స్ ఆఫ్ ద సౌత్ పోల్. Am I right? Are you clear, Pawan? First conductor under the influence of the north pole, that is the 1. 6 అనేది ఇక్కడ second conductor under the influence of the south pole. Okay, am I right? So similar way, so 9th conductor చూడండి, ఇక్కడ 9th conductor అనేది, so it is also first conductor under the influence of the north pole. Okay, these are the north pole, right? So 4 conductors are under the influence of the north pole. So next one, 14th conductor ఎలా ప్లేస్ అయినది? సో ఇట్ ఈస్ ద సెకండ్ కండక్టర్ అండర్ ద ఇన్ఫ్లుయెన్స్ ఆఫ్ ద సౌత్ పోల్. సో ఈ కాయిల్లో ఫస్ట్ కాయిల్లో కాయిల్ సైడ్ 1 is a ఫస్ట్ కండక్టర్ అండర్ ద ఇన్ఫ్లుయెన్స్ ఆఫ్ ద నార్త్ పోల్. కాయిల్ సైడ్ 2 is a సెకండ్ కండక్టర్ అండర్ ద ఇన్ఫ్లుయెన్స్ ఆఫ్ ద సౌత్ పోల్. సో ఇన్ కాయిల్ 5 ఆల్సో 9th conductor is a first conductor under the influence of the north pole. So now 14th conductor is a second conductor under the influence of the south pole. So it is similar. These two coils are in the cylindrical structure machine. So these two coils are same. So same, having the same potential. So that's why it is treated as a equipotential coils. So that's why here is if there is no equipotential coils, then what will happen? Circulating current flows from the coil 1 to coil 5. So there is a equipotential coils, then no circulating current flows in these coils. So only circulating current flows within the ring. If any circulating current occur, short circuit current occur in the winding, so this ring provides the low reluctance path. So that's why this circulating current within the ring only, not in the winding, so that you can protect the winding. So from the any circulating current or unwanted current in the armature winding. Okay. All of you clear now? Yes or no? Is it clear, everyone? Equalizer ring is designed with the thick copper wire. Okay, thick copper wire or conductor. So that is the copper wire. Okay. So now area of the cross section is I, so that it offers the low resistance. So now problem of circulating current between the any two parallel paths is more in the lap winding. So equalizer rings are required. Okay. So equalizer rings are connected between the equipotential coils. All of you clear my point? So how do we put here? This is the equalizer rings. So it is a coil 1 and coil 5 are the potential in lap winding, that is the lap winding. So in the example, okay, which is shown in the figure, lap winding means which is shown in the above figure, shown in the figure. So that is a coil 1 and coil 5 is a equipotential coil. Coil 2 and coil 6 is the equipotential coil. So coil 3 is a coil 7 is a equipotential. Coil 4 and coil 7 is the 8 is a equipotential coils, right? So now we have a question, the number of the equalizer rings. Okay, number of equalizer rings. This is also very important. equalizer the rings. Not 180-degree displacement, two pole pitches. So that is the number of equalizer rings is equal to number of the armature conductors okay, divided by so pair of poles here. So here number of armature conductors divided by pair of the poles. So number of conductors is equal to Z, pair of the poles is equal to P by 2. Okay, P by. So therefore number of equalizer rings is equal to 2Z by P. Okay, 2Z by P here. So now this is the formula to get number of the equalizer rings required. So this is the 2Z by P values here. So always pair of the poles, we have written pair of the poles means, so this equipotential coils, okay, between the two pairs of the poles. Okay, it is North Pole and South Pole, this one is the North Pole and South Pole. So number of the coils between the two pair of the poles. That's why we have written number of the armature conductor divided by pair of the poles. (180-degree) displacement is termed as a equipotential. Is it correct? No, it's not correct. Equipotential means that is a no EMF induced between there is no potential difference between the two coils. That is the equipotential. Potential difference is equal to 0, absolutely 0 at any instant of the time. Next, one more question we have. Sometimes we have a question, number of the conductors, number of conductors between the positive group of the brush and negative group of the brush, or number of the slots between the positive group of the brush and negative. So where slot is equal to, this is the slots are is equal to, so we can represent slots is equal to the S. Okay, got it? And next one, what about the number of the conductors here? So this one is a slot is equal to S and conductor, that is represented with the Z value here. Conductor is a Z and number of the poles is equal to P number of the poles. So there was a question in the competitive exam, how many conductors between the positive group of the brush and negative, between the two consecutive positive group of the brushes and next negative group of the brushes. Anyone can tell you this answer? Number of the armature slots between the consecutive positive group of the brush and negative group of the brush. Consecutive means side by side. Successive. Very important question. Problems point of view. This is the one of the question. Find out the generated voltage between the conductors, or find out the number of conductors between the positive group of brushes and negative group of brushes. Anybody? Have we got it? Positive group of brushes and negative group of the brush. Y plus 1, see, I am asking about the conductors between the positive group of brush and negative group of the brushes. So each parallel pass, for example, see from here, we have started from here, see. This is the one conductor, right? Conductor 1, conductor 2, conductor 3 and conductor 4. Okay, this the number of the each 4 conductors are connected in series, act as a one parallel path. So which is connected between the positive group of braces and negative group of braces? How many conductors are there? How many conductors? Four conductors only. Okay, just I am asking about how many conductors between the positive group of braces and next negative group of the braces. So this is the conductor 1, conductor 2, okay, conductor 3. Okay, now this one is conductor 4. Okay, this is conductor 4, eighth one. Two z by p plus 1. It's not correct, Sanjana. I'm asking how many conductors between the positive group of brace and negative group of braces. That is the number of conductors per each parallel path. Now clear now? Okay, sixth observation. Okay, sixth one. So let assume the slots of the armature core. Okay, slots of armature core is equal to S, and number of the conductors, okay, Z is equal to, Z is a number of conductors. So this Z is equal to 2 times of the S. So this is for the double layer winding. Okay, double layer. Okay, Z is equal to the S is a single layer winding. Okay, Z is a 2 coil sides, double layer and single turn coil. So then only it is a possible. Z is equal to 2 times of the S. Okay, right? So now we have a question where P is the number of the poles. Number of the poles is equal to P. So here, our question is a number of the slots. Okay, number of the slots between the consecutive group of positive brush and negative brush here. Okay, this one. So how many slots between the positive braces and the negative braces here? So that is equal to number of the slots per pole. Okay, number of the slots per pole. So next one. So here is a, suppose for this case, okay, slots per pole. So example point of view, okay, here slots is equal to 8. Okay, conductors are is equal to, okay, that is the 16. Number of the poles is equal to 4. So now here the number of the slots between the positive braces and negative braces. So how much here? This value is equal to the number of the slots, okay, slots between the consecutive positive brush and the negative brush. So how many slots here? 8 by 4 is equal to 2 number of the slots. Suppose if you want to find out the conductors, so number of the number of, okay, conductors, okay, between the consecutive positive brush and the negative brushes. So now this is equal to, what is the formula? So just like a one parallel pass, number of conductors per parallel pass. So now there is a Z by P here. So now in this case, okay, it is equal to how much? Okay, for same example point of view. So if we take the 16, okay, divided by 4, So that is equal to 4 number of the conductors. Okay. So very important question. The mostly especially in the transco, genco type questions. So this type of question will ask in the competitive exams. Number of the slots between the positive group of the brace, positive consecutive braces and negative braces, and number of the conductors. Okay, these two questions. All of it clear now? Yes or no? So these are all possibility questions from the lab connected armature winding. So now we will discuss some questions based on the lab connected armature windings. Okay, this is the one of the question which was given in the IAS. Okay, a 4-pole lap wind. Okay, 4-pole lap wind. Just wait a minute. Okay, I will give the question. Just okay, wait a minute. It's not the correct question. Okay, question given like suppose a 4-pole lap connected DC machine or DC generator generates the voltage of E volts and develops power of P watts. Okay, one brush is removed. Removed due to some reason. If machine is operated with remaining braces, then generated voltage and power developed will become okay, option A E comma P. Okay, option B E by 2 comma P by 2. Okay, option C E comma P by 2 and option D E comma P by 4. Okay, this is our question. Okay, now solve this question, all of you. First read the question, then we can answer the question easily. A 4-pole lap connected DC generator generates the voltage of the E volts, okay, and develop the power of the P watts. Okay, under steady state condition. One brush is removed due to some reason. Okay, suppose brush worn out, any other reasons. So if the machine is operated with the remaining brushes, then the generated voltage and power developed will become. Okay. So here is a 4-pole lap connected. Given number of the poles is equal to P is equal to 4 and the lap winding. So therefore the number of the parallel paths A is equal to P. So now it is equal to 4. Okay, and number of the brushes is equal to, okay, number of brush required or brushes is equal to, so that is the number of the parallel paths, so that is equal to, so 4 brushes, okay, 4 brushes is required. Okay, so now initially suppose, okay, there is a one brush, okay, this is the brush 1, okay, let us assume positive group of the brush, and this is the brush 2. Okay, here I have taken brush 2, it is a negative group of the brushes. So take circular manner, okay, that is the brush 3, okay, positive group of the brushes, and this is the negative group of the brushes. Always parallel path is connected between the positive group of the brush and negative group of the brushes. Suppose here parallel path 1, okay, this is a parallel path 1 and this one is the parallel path 2, okay, like parallel path 2, and this is the parallel path 3. Okay, all of you got it? So now this is the treated as a parallel path 4. So let us give the numbers. Okay, it is a P1 and it is a P2 and this one is the P3 and it is a P4. Okay, number of the parallel path 1, parallel path 2, parallel path 3 and parallel path 4. Okay, so now here the two positive group of the brushes are connected, right? Okay, this is the positive group of the brushes, so are connected. Okay, this is the positive group of the brushes are the connected. Okay, started. And next one, two negative group of the brushes are the connected. Okay, like so on. So this is the negative group of the brush. Okay, so in case of the generator, what will happen? So this is connected to the positive terminal of the load and this one is connected to the negative terminal of the load. Okay, like so this is the load current, I amount of the current I, and the voltage here, okay, this is the voltage E amount of the voltage. Okay, each parallel path produces the same amount of the voltage, like. So now what under steady state condition, what will happen? See, so under steady state condition, okay, under the steady state condition, okay, now generated voltage, that is the initial conditions under steady state condition 1. So that is the generated voltage, this is equal to generated voltage. So that is a E1 is equal to the V amount of the volts. Okay, V volts here. Now what about the current here? Current in the each parallel path. How many number of the current here? So this is the current flows. Okay, current, that current in the, okay, this is a total current here. Current passes to the load. So that is equal to current here. I1 is equal to current. Okay, here current generated voltage and current I1 is equal to, so that is the I amount of the current. So where I in the sense it is equal to I by 4 plus I by 4 plus I by 4 plus I by 4. So it is represents current per path. Okay, that is the current per path here. So this is the total current I1 is equal to, So now this is the I amount of the current. Okay, that is the I by 4 current per path. So next one. So these are all are under steady state condition. Okay, steady state condition. So what about the power here? Power developed in this case. So power developed under this condition. So it is denoted by the P1. So it is equal to E1 multiplied by I1. Okay, E1 multiplied by I1. So V1 I1 in the sense, okay, it is equal to E into I. So that is denoted by the P amount of the power. Okay, this. So now question is, if one brush is removed due to some reason. So here is a, so if one brush, the brush is removed, okay, brush is removed due to some reason, then what is the power developed in? So how do we remove here? Suppose that is a current flows in this path. Okay, suppose one brush is removed means, so we are removing any one of the brush. Suppose I am removing here, one brush is removed. So therefore here what will happen? The current in this path here, current here. So this I by 4 is equal to 0. So it is a open circuited here. Similarly, current in this path also equal to I by 4 is equal to, will become 0. Only two paths are existing. Suppose here, what is the path? So this is the path like this. So I am showing here. So this is the path flows, okay, only here. Okay, only here. So now this is the coming. Okay, next one. So this is the coming from here. So now, okay, like, and this is a complete my direction of the currents. Okay, like, so now here from this case, so like, so how many paths are existing in between the load here? Only two parallel paths are existing. So but generated voltage remains same. Why? Because generated voltage, the E2 is equal to E1. So that is equal to E. And but what about the current here? Current, okay, if the one brush is removed, so current I2 is equal to I by 4 plus I by 4. So why? Because this current will become 0. It is a open circuited. So that's why what will happen? I by 4 and I by 4 is equal to, so I by 2. So what about the power developed? So power developed, that is equal to P2. So it is a E2 multiplied by I2. So now this is equal to the V and I by 2. So now it is equal to P by 2. Okay, P by 2. So that what is the answer for this question? Generated voltage, okay, E is equal to generated voltage E. Are you clear point? Generated voltage is a E and power developed is the P by 2. Okay, option C is a correct. Very good, Satish. You have given correct answer. Are you clear now? Is it clear, everyone? Yes or no? Okay, all of you got it? Understand this? Have you understand about this problem? Very important question. Okay, so now let us solve one more question. So which was given GATE 1999. The same concept. Here a 4-pole lap wound DC generator has a developed power of P watts and generated voltage of E volts, two adjacent braces of the machine are removed as they are worn out. If the machine operates with the remaining braces, the developed voltage and power that can be obtained from the machine are. Okay. Option C, E comma P by 4. Okay. So two adjacent braces. Okay, similar way. So that is a we can take like, so that is the positive group of braces. Okay, negative group of the braces. Okay, positive group of the brace and negative group of the braces. So now always parallel path between the positive group braces and the negative group braces. Okay, P1, P2. Okay, now P3. Okay, P1, P2, P3. Okay, P4. So it is a, let us positive, negative, positive, and the positive, and this one is the negative. So here is a, okay, this is the P1, the P2. Okay, this one is the P3, and this path is a P4. So always what I conclude here. So positive group braces are shorted like, okay, this the positive braces, okay, and the two negative braces are also shorted. So load is connected between the positive group of braces and the negative group of the braces. So here in between the load is a connected line. So under steady state condition, so under the steady state, okay, steady state condition, so what will happen, that is a E1 is equal to, so E1 is equal to E, okay, generated voltage, and I1 is equal to I amount of the current. I in the sense, so that is the I by 4, sorry, I by 4 plus I by 4 plus current in the each parallel path, I by 4 plus I by 4. So that is the I amount of the current. So if if the two adjacent braces, okay, here is a, the two adjacent braces are removed. Okay, if two adjacent braces, adjacent means so side by side, adjacent braces the removed, adjacent braces removed, then what will happen? So adjacent braces removed means, so let us take here positive group of brace and also here negative group of the braces. Only how many parallel paths? If two adjacent braces is removed, so that is a 3 parallel path will become open. The parallel paths will become open. So no current flows in the 3 parallel paths. Only current flows here. This current only present. This current is equal to I by 4. So here this I by 4 is equal will become 0, and this current is I by 4 also equal to 0, and here I by 4 also equal to 0. So that's why we can write, so generated voltage is equal to generated voltage. So that is the E2 is equal to the E1. So it is equal to E. So but current is equal to, okay, that is a, so I2 is equal to I by 4 only. Okay, I by 4. Remaining current will become 0. So now power developed is equal to how much? Okay, power developed. So that equal to P. So E2 multiplied by I2. So that is the E comma I by 4. So it is equal to P by 4. So that is the E comma P by 4 is the answer. Very good. E comma P by 4. Suppose same question. Okay, here in this question two adjacent braces are removed. Suppose question is given, if two opposite braces are removed, then what is the answer? If two opposite braces are removed, then what is the answer for this question? Generally, I am asking you, in the same question, two opposite braces are removed. If two opposite braces are removed, then what happens? current is 0. Okay, and also power is equal to 0. No parallel paths existing between the load terminals. So that's why power is equal to 0. Very good. So now solve this question, all of you. A 6-pole lap-wound DC generator has developed power P and two adjacent braces are removed. They are worn out. The machine is operated with the remaining braces. The developed voltage and power that can be obtained from the machine. Okay, now tell me the answers for this question. E comma P by 2. So first one, your lap winding. So how many number of the parallel paths, number of poles are given? 4. Okay, it is a lap winding. So that's why number of parallel paths is equal to P. So it is equal to 4. And number of the brushes here, number of the brush. So that, sorry, it is a 6 poles, right? So number of the parallel paths also 6. So number of the brush also here 6 number of the brush. So now let us solve this question. So 6 braces, okay, positive braces, okay, negative braces, okay, positive braces, okay, negative braces, positive braces, and the negative braces. Okay, I have taken positive, positive group of brace, positive and negative and positive, negative and positive brace. Sorry, I have taken reverse. Okay, it is a positive, negative, okay, positive and the negative. So here parallel paths, okay, parallel path 1, okay, parallel path 2, parallel path 3, parallel path 4, parallel path 5, parallel path 6. Okay, P1, P2, P3, P4, P5 and P6. So how many here initially under steady state condition? Okay, under steady state, okay, initial conditions. So here E1 is equal to the V and I1 is equal to I. So this I is nothing but I by 6 plus I by 6 plus I by 6 plus I by 6, okay, I by 6, okay, plus I by 6 1. Okay, this is the I1 amount of the current. So next, if two adjacent braces are removed, two adjacent brace is a removed. Brace is a removed. So braces are removed. Then what will happen? See, the two adjacent braces are the removed. So here is a, okay, what is the two adjacent braces? One positive group of the braces and negative group of the braces. So current in this path I by 6 is equal to 0 and current in this path I by 6 is equal to 0 and current in this path also equal to I by 6 is equal to 0. So therefore here E2 is equal to the V1, so that is the E, and I2 is equal to, okay, here I by 6 plus, okay, I by 6 plus I by 6, so that is equal to 3I by 6. So it is a I by 2. So now power is equal to P2. So here E2 multiplied by I2. So E2 is a E I by 2. So that is a P by 2. So answer for this question E comma P by 2. All of it clear now? Option D, very good. Option D is the correct. E comma P by 2. So now answer this question. In DC machine, for the same values of the phi Zn, Which of the following statement is correct? Okay. Which of the statement is correct? Option A. Armature EMF is more with a wave winding. Already I mentioned this point in the last class. That is a lap winding is used for. Okay, lap winding is used for high current and low voltage. Okay, so wave winding is used for so high voltage and low current applications. Low current application. Okay, so option A is a correct. That's correct. So now solve this question. So it is also one more possibility question based on this concept. A 6-pole DC armature, a simplex lap connected. Simplex mentioned here. Simplex lap connected 720 conductors. So 3 slots per coil and 3 slots per coil. Okay, and 4 coil sides per slot. Or 3 turns per coil and 4 coil sides per slot. Determine the number of the slots and in the armature and state whether the equalizer rings are required or not. So it is a lap winding, right? So equalizer rings are the required. Are clear point? So when it is a lap winding, equalizer rings are required. That's why it is a not possible. 2 options are there. Okay, this is not correct and also this is also not correct. Okay, equalizer rings are the required. So that maybe 30 slots and possible equalizer rings are required, or 30 slot or 60 slot. So now let us find out here number of the conductors. Number of conductors. The conductor Z is equal to, so number of the slots. Okay, slots, number of slots S. Okay, multiplied by, okay, this is the coil sides per slot. Okay, coil side per slot. Okay, multiplied by, okay, now conductors per coil side. Conductor per coil side. Okay, this is the formula. Number of conductors is equal to number of the slots, coil sides per slot. Okay, conductors here. Suppose here there is a slot, okay, like this. So we are placing, okay, this is a 1 coil side. Okay, here 4 coil sides are there. The coil side 2, okay, coil side 3, and 4 coil side we are placing. So coil side 3, coil side 4. So here how many each coil side has 4 conductors. Okay, like so 1, 2 and the 3, 4 conductors are there. Now here also 4 conductors, 1, 2, 3, and here also we have a 4 conductors. Okay, and here also we have a 4 conductors. Okay, 4 conductors. This is the 4 turn coil. Like this is nothing but 4 turn coil. Okay, 4 turn coil. So now we have to find out. So this is the 720 conductors. Number of slots, that is the S, and how many coil sides per slot? 4 slots per, and how many conductors per coil side? It is a 3 turn coil or 4 turn coil. So 3 turn coil is there. So that's why it is a 1, 2 and 3 conductors. So 1, 2 and 3 conductors. So now 1, 2 and 3 conductors. So 1, 2 and 3 conductors. So now 4 coil side and 3 conductors. So conductors per coil side is equal to 3. So therefore here S is equal to 720 divided by 4 by 3. So now simplify this. you will get 60. Okay, this is the 60 number of the slots. Got it? So that answer for this question, 60 slots and equalizer rings are required. Okay, all of you got it? We understand this about the lap winding. So this was the discussion about the lap connected armature winding. Tomorrow we'll discuss power electronics, and on Monday we'll discuss about wave connected armature winding. All of you got it? Any more question do you want to ask? Okay, this is the official Creatrix channel. Please join in this group, and it is Unacademy GATE Telugu Telegram group. For any updates from the GATE Telugu Telegram group, Telugu team, please join to get all this announcement and class notes. Okay, these are the different type of channels under the Unacademy. One is a Creatrix EEE EC Instrumentation, Unacademy Mechanical, Unacademy Civil, Unacademy GATE Telugu and Electrical Junction, Unacademy GATE Questions, Unacademy Computer Science, Unacademy SSC JE, Unacademy Engineering Foundation, Engineering Pathashala. Okay, so thank you all. Thank you very much. Yeah. Today I will upload Sanjana. నేను అప్లోడ్ చేస్తాను ఈరోజు ఈ క్లాస్ లెక్చర్ అండ్ లెక్చర్ నెంబర్ 50 ఆల్సో బోత్ ఐ విల్ అప్లోడ్. Any more question do you want to ask? Is that clear everyone? Have you understand?